Hello everyone, let's take a look at LeetCode 426. Convert binary search tree to sorted double linked list. It's a lot of problems and it appears in a lot of interviews, for example, in Facebook. And this question actually, it's involved a lot of knowledge, for example, trees and linked lists. Okay, let's take a look at problems. So here it says we can think of the left and right pointers as synonymous to the predecessors and successor pointers in a double linked list. For a circular double linked list, so the predecessor of the first element is the last element. So it asks us to, like, for the first node and last node, we also need to connect them. Okay, so let's take a look at the first example. So you ask to convert this binary search tree to this double linked list 1.2, 0.3, 0.4, 0.5. So let's take a look at how to solve these problems. Okay, so this is our example, and this is the main function. We just do a corner case check. If the root is non-pointer, then we just return non-pointer. And here I prefer to use in order traversal. Since in order, so in a BST, if we use in order traversal, then we just for access 1, 2, 3, 4, 5, same as this order. Okay. Yeah, I will use two local variables. One is preview, one is head. So next, I want to call this in order function. I want to set head at node 1 here, and at last preview will be 5, the last node. So I can connect the head node and the last node, for 1 and 5. So I can connect them at last. So I will call in order function here and pass preview and head. Since I need to update preview and head, I don't want to make them just a copy. I want to update them. So I pass the reference here for preview and head. Okay, so first problem here is how can we update head correctly? We know head is node 1, but how can we update it? So we know that for in order function, first we will pass the root. But we know root is not our head since root has left children. So next, we will visit 2, but 2 is also not our head. Next is 1. We know at this point, head is still non-pointer, and the node 1 does not have left children. So node 1 is our head. We will assign node 1 to head. So we only update head once, since head will not be non-pointer next time. Okay, so we can update head. You use this line. Okay, next, how can we update the preview? So we can update preview here. So once in order finish, the preview will be the last node we visited, the node 5. So at last, preview will point to node 5. After the in order function, we can connect the preview and the head. Okay, next, let's see the main function here. So first, assuming we are at node 4, since we first call in order root, node 4 is our root. So this is our left node and this is our right node. Let's see how can we recursively connect them. First, left is not non-pointer, so we can recursively call in order left, and we 100% trust the recursive function in order. We trust the in order function can connect my left children, make my left children a double linked list like this. 1, the right node of 1 will point 2, and right of 2 is 3, and the left of 3 is 2, the left of 2 is 1. So I trust my in order function can make my left children like this. Okay, and my preview will be point to 3, 1 in order finish, since preview will point to the latest node I visited, which is 3. Okay, now I'm at node 4, so I can connect 3 and 4. So the right pointer of my previous node will be 4, and the left pointer of my current node will be 3. So I connect 3 and 4. So 1, 2, 3, 4, already done. Okay, next we need to finish the right part. Okay, previous 4 now. If we have right node, then we just call in order right. We know in order function, we will connect the current node and the previous node. So when calling order 5, I will connect 4 and 5. Okay, so we just finished. And at last, I need to connect node head and node preview, which is 1 and 5 in this example. So that's this problem, and it's actually a very common problem. There are many similar problems in LeetCode. I think the most important part is this previous node. Since if we have this previous node in each iteration, for each current node, we have the information about, like we have the information of the previous node we just visited. So we can do some operations between previous node and my current node. For example, connect them or other operations. Okay, that's the problem. Thank you. See you next time.